Today we are starting Unit 1, and Unit 1 is transformations, and we're going to end up introducing parent functions. And what is a parent function? So what do you wonder about parent functions when you hear that word parent functions? Just give you a minute to think about. So what is a parent function? A parent function is basically the basic or standard function used to transform functions or change. Whenever I think about it, think of transformers. What happens to transformers? Well, they're cars or trucks, and then they end up changing into robots. They transform. There's something that happens, and they end up becoming the Autobots or Megabots. So that is a similar what happens to a parent function. You are changing it. You're doing something to it to make it look different. But we first need to learn what are those parent functions we're going to be talking about. So the first one that we have is a linear function, and you're familiar with linear function. We just ended up doing a lesson on linear functions, graphing them, which is the y equals x. Next one we have is a quadratic, y equals x squared, and then a radical or square root. Those are the three that we're going to actually end up seeing today. One of the things, I know that that's a radical symbol. Okay, the square root is a radical symbol. I know here it does not come out completely, but just write it in. And then tomorrow we'll see cubic, cube root, and absolute value. So starting off with the first one, which is a linear function. Here's our linear function. So I have the form y equals x, or I like to say f of x equals x. It's the same thing. Remember, f of x is a fancy way of saying y, okay, our f of x. So how are we going to fill this up? Well, we're going to end up starting with values on the x-axis that are negative. So we're just going to write them in. We're going to start like that, negative 3. So if x is negative 3, that means that y, or our fancy f of x, is also negative 3. So my coordinate is negative 3, negative 3. Make sure you write it as a coordinate, okay, with parentheses around it. I have negative 2. Again, my output, my f of x, is negative 2 as well. Write my coordinate, negative 2, comma, negative 2. We're going to do a couple more. Make sure you're writing these down on your notebook, so you can also have the graph of these functions. We have 0, just 0. And we end up with positive 3. Okay. So make sure we're going to end up now graphing it. So doing this on graph paper is very important. So we're just going to graph our function. And so we have our first point, which is at negative 3, negative 3. So we're going to go down the x, go down to negative 3, negative 2, negative 2, negative 1, 1, and you'll see your familiar function of a linear function. Okay. And we end up making a line. Okay. So that's our first function. Now let's go on to our next function. which is our standard quadratic function. X squared. Most of you are familiar with seeing x squared in Algebra 2. So again, we are going to start out with negative values. So I'm just going to write my values I had from before. -2, -1, 0, 2, 3. But now my function says to square it. So a -3 squared is -3 times -3, that's a +9. -2 squared is -2 times -2, which is +4. -1 would be 1. 0 squared is just 0. 1 squared is 1. 2 squared, 4. And 3 squared is 9. So now we just write these as coordinates. So go ahead and end up writing them. I'm going to do a couple of them. You guys could finish the rest of them on your notebook paper where you are taking your notes. And now let's graph them. So we'll go ahead and take a moment to be able to graph those points. So we start at -3, +9. That's your first point. -2, +4. 0, 0, -1, -1, 1, and 0, 0. One thing you're going to notice with our quadratic function is that it reflects across the y-axis. And it looks, I always tell the students, it looks like a U. I know your sketches are going to be much better than mine. So mine's a little bit off, but just so you get an idea. Okay, remember you could pause the video at any time. Let's go to our last one for today, which is our square root function. So square root is the inverse of quadratic. Okay, so let's look at that. And with the square root function, you could only take the square root of positive numbers. Okay. I cannot take the square root of a negative because that would be imaginary. Okay. And we'll learn about that. So square root, if you think about perfect roots, that's one of the things. Think of all your perfect roots. And so if we start with x being 1, we could do 0. We could start at 0. Can't do that. Because the square root of 0 is just 0. And then we could do 1, because the square root of 1 is 1. Now 2, square root 2 is an irrational number. That's a decimal, so I don't want to do that. I want to go to my next perfect root, which would be 4. Because the square root of 4 is 2. The next perfect root is 9. Square root of 9 is 3. The next one is 16. And that would be 4. And so on and so forth. So again, we write them as coordinates. Don't forget to do that part. Very important. Start you up with a couple of them. And then you could finish the rest. So now when we end up graphing it, we're going to start with 0, 0. Then go to 1, 1, right 1 up 1. 4, go right 4, 2, and then 9, 3. And that's the last one that's going to fit on our coordinate plane that we have here. If you notice, it kind of curves. So it's kind of like half of my quadratic function, but rotated. Okay. Hopefully that helps. Tomorrow we'll do the next 3. I have one more thing. If you have any questions, feel free to email and make sure that you have these graphs. Okay. We will see you tomorrow.